السلام عليكم دكتور.
Waalaikumsalam warahmatullah. What slide number we stop?
Like 50, Doctor.
50.
Yeah.
Thank you. Okay. Bismillahirrahmanirrahim. Assalamualaikum and good morning to all. Okay. Selamat berpuasa for the Muslim brothers and sisters. Right. So we continue. Inshallah. Slide number 51. Rule number 7. Okay. So we already look into the rule number 1, 2, 3, 4, 5, and 6. Now we move to the rule number 7. So rule number 7 is intersection between root locus and the imaginary axis. So this is your imaginary axis. Okay. And this is your real axis on the S-plane. Okay. So the root locus is the blue line. Okay, this one is the root locus. Okay, is the root locus. Okay, so we are concerned on the intersections between the root locus and the imaginary axis, which is located here. Okay, and here is the symmetry lah, dia punya symmetrical dia. But we always looking at this point because as you know in the theory, in S-plane, okay, this part from the imaginary towards the left, we call it as a left half plane, or we call it as a stable zone. Okay, stable. But on the right hand side or right half plane is a non-stable zone. Okay. So, but on the top of imaginary axis itself, okay, is considered as the critical part or the marginal part. Okay, so please remember these three locations on S-plane: the stable zone, non-stable zone, and critical zone. So when the imaginary axis crossing a point on the root locus that separate the stable and unstable operations, we have to find the value and the corresponding gain that occurred on these intersections. For that purpose, we have to use the tools, which is known as a Routh-Lewis criterion. So in exams and in tests, okay, you are given this plot. Okay, you are not required to draw the root locus. Okay, you are given this plot. Okay, and you observe the value. Okay, so if I observe the value here, okay, over here, so it is roughly about positive J 1.8 something. Okay, that is by observation using your eyes. But the question always asks, validate your observation. Sorry. Validate your results. Okay. Positive J 1.8. So how are you going to do it? How are you going to prove? Okay. This value 1.8. So we have to use a tool. The tool is known as a Roth-Lewis criterion. So as you learned in the control one previous semester, Roth-Lewis table, in order to put a value in this table, you need the characteristic equations. Characteristic equation. Okay. So these characteristic equations come from the closed loop transfer function, which is T of S C over R. Okay, closed loop transfer functions. So for the closed loop transfer function, we focus on the denominator part. This denominator part is equal to 0. So when this denominator part equal to 0, it is known as the characteristic equations. Our concern is on the coefficients of these polynomials, which is A4, A3, A2, A1, and A0. And these coefficients will be inserted inside the Roth table as shown here. A4, A3, A2, A1, A0, and A0. And then you have to fill up, okay, to fill up the tables, okay, using the formula that's shown here, which is A4, A3, A2, A1, negative. This is known as a determinant. Okay, determinant, where you cross multiply A4 and A1, A3 and A2, A4 and A1, A4 multiplied by A1 minus A2 multiplied by A3. Okay, then negative, and then divide by A3, then you get the value of B1. Okay, so same as here as well. Okay, A4, A3, A0, 0. Okay, and so on. So if you forget this table, so please refer to your previous notes as well. Okay. So in Roth-Lewis criterion, we have two special cases where 0 in the first column and row of zeros. Okay. So let me remind you. Okay. Okay, so this is column and this is a row. Okay, so please don't mix up, right? So first case is 0 in the first column, so we replace the zeros with the epsilon. Okay, epsilon. So this is the examples. Okay, where this is the closed loop transfer function TS, and the denominator is the equal to 0 is the characteristic equation. So we insert the value for 1, 2, okay, and then 3, 6, and 5, 3. So we see that the 0 in the first column occurred. So we replace with the epsilon. What is epsilon? Epsilon is the representative of small positive and negative number. Okay, small positive and negative number. Let's say you choose as positive 1 and negative 1. Then you insert inside the formula and see the sign. Okay, either positive or negative. The second case is the row of zeros, where the entire row is 0. It happened in these examples. Okay, S5, 7, S4 plus 56 equal to 0. Okay, and then you insert inside it and you it happened at S power of 4, the entire row is 0, then you replace it with this technique, which is auxiliary equation, S power of 4, 6s squared plus 8, differentiate, and then you replace the 4, 12, and 0 in the table. Further details, you can refer to the Control 1 notes previous semester. Example 6. So example 6 is shown here is for the system shown below, find the frequency and gain K, okay, for which the root locus crosses the imaginary axis, and then for what range K is the system is stable. Okay, so this one is open loop transfer function. So when you going to find the closed loop transfer function, how are you going to do it? Nur Hazika, Shazwina, are you there? Nur Hazika? Selamat datang. Next guy, Ahmad Farhan.
Ada, Doktor.
What is the open loop transfer function? Just now?
-1.
Mana ada negative? The open loop transfer function in the box tu.
At the bottom.
As written in your notes tu. Ni ni.
S plus 4.
S plus 4 kan?
Yes.
So close loop. Okay. Okay. Datang. Syahin. Close loop transfer function. Tak tahu habis. Mana ni? This one is the closed loop transfer function. Ifzul? Ifzul? Tak. Bagus. Matthew?
Yes, Doctor.
Characteristic equation?
Characteristic equation S power 4 plus 7s power 3
Yeah.
plus 14s power 2 plus bracket 8 plus k bracket s plus 3k
Okay. Equal to 0.
equal to 0.
Don't forget that. Okay. So I take from the denominator here equal to 0. But Matthew make our life easy by reading from the notes, page 55, correct?
Yes.
Okay, never mind, it's okay. So 1, 7, 14, 8 plus k, 3k. So what is the value below 3k? Chong Jawan.
0.
0, 0, not 0, 0. Okay. So 90 minus k. So how do I get this? 90 minus K. Tanya lah, lupa kan. Tu kan. Farid Naim. Farid Naim. Tak datang.
Appreciate.
Datang tak datang? Farid Naim tak datang eh? Adam? Adam Amir?
Yes, Doctor.
How do you get 90 minus K? One seven
Hello.
17 14 8 plus K. Okay. Divide by 7. Okay. So you will get 90 minus K, same to 21K, and this one is 0 as well. Then continue the fill up until the end, S power of 0. This one is 0, 0, 0, 0. Okay. So in this case, row of 0 yield the possibility of imaginary exist poles. I think this case have a row of zeros, never mind. You follow the previous slide in the previous note last semester, how you overcome the row of zeros. My concern now is how we going to find the range of stability. So in the theory, for stability, the first column must greater than 0. So where is the first column? The first column is here. So this is the first column. The one that I circle is the first column. Okay. So 1 is greater than 0, fine. 7 is greater than 0, fine. Then 90 minus K. Okay. 90 minus K greater than 0, minus K greater than minus 90, then K is less than 90. Equation number 1. Okay. Then this one, minus K, minus K2 plus 65K, 7 to 0. Minus K square, minus 65K, plus 7 to 0, greater than 0. Okay, so then there is a fraction of it, 90 minus K. Okay, so you multiply, so tinggal K square plus 65K minus 7 to 0 greater than 0. So this one you have to simplify, okay? And then 21K greater than 0, then K greater than 0. So this is equation number 2, this is equation number 1. Okay, so it happens that for this, when K is equal to 9.65, it will satisfy these equations. Okay, so therefore the range of stability is 0, less than K, less than 9.65. So now, when K is equal to 9.65, this is where the critical gain happen. Okay, critical gain happen. So forming the even polynomial from the Ruth table, which is on here. This one, 90 minus k s square plus 21k equal to 80.35 s square to 202.7. You insert this value inside the even polynomial equations, then you find the roots, which is plus minus j 1.59. Okay, so hence the root locus crosses the imaginary axis at plus minus j 1.59, and the range of stability for the system is 0, less than k, less than 1, meaning that 0.1 until 9.64 stable. So when it equal to 9.65 is critical. When it's equal to 10 is unstable. Okay. So we draw the root locus. Okay. So somebody help me. Chua Le.
Yes, doctor.
Apa khabar? Okay, give me the open loop transfer functions. G equal to 5 s plus 3. K equal to 1, K equal to 1. So s plus 3 divide
S times S plus 1
S times S plus 1
times S plus 2
S plus 2
times S plus 4.
times S plus 4. Okay. Then R locus G and then grid. Okay. So we switch to MATLAB. Can you see my MATLAB, guys?
Yes, doctor.
TF. Then G is equal to S plus 3 over S multiplied S plus 1 multiplied S plus 2 S plus 4. Okay. And then our locus. Okay, and then grid. Can you see the root locus? Guys, can you see the root locus?
No,
Why? Why?
you haven't shared it.
Okay, I haven't shared it. Now you can see. Okay. Oops. Okay. Okay. So actually you can focus it. You just press the magnifying glass there, positive. Okay, and then you focus on the one that you want to the poles and zeros location like that. Okay, become bigger lah, kan? Okay, you get the tips. You get the tips or not? Okay, I share in the WhatsApp. Can you see in your WhatsApp? Okay. So So how are we going to find the intersections between the imaginary axis and root locus using computer? Chung Hoi Ki.
Yes.
How are you going to find a point intersection between imaginary and root locus?
Find the pole.
Using the mouse lah. Huh? Chong, using the mouse lah. You don't use the mouse, you cannot get lah. So 1 point. This one. 1 point.
1.65.
1.65
Ah.
okay. Itu dia 1.65. Betul ke? Itu betul 1.62 lah. Okay. But the damping still negative lah. 1.59 lah. Okay. You can see there. That is the intersection between the root locus and imaginary axis. Okay. Right, so it's happened here, J 1.59 here. Okay, and the asymptote as well. So next one is the angles of departure and arrivals. So angle of departure and is always referred to pole pairs, and the angles of arrival always refer to zero pairs. It can be calculated to further refine the sketch, okay, by use the complex open loop poles and zeros. Okay, so kalau ada complex conjugate poles, so this one refer to departure angle, but if complex conjugate zeros, it refer to arrival angle. Okay, so the root locus depart from complex open loop poles and arrive at complex open loop zeros. So it is the what you call that the root locus basic, where root locus starts from poles ended at zeros or infinity. And the formula to calculate is basically using the angle property, okay, angle criteria, which is theta arrival is equal to total of angle of all poles to be minus angle of all zeros to be plus 180 degrees, while theta departure is total angles of all zeros to A minus the total angle of poles to A plus 180 degrees as shown here. Okay, so the left one is the angle of departure, okay, which is referred to the complex conjugate poles, and the right one is the angle of arrival referred to the angle of zeros. Okay, yeah, departure yang ni. Okay, so kita gunakan angle criteria. So minus theta 1, y minus because it referred to the poles, plus theta 2, theta 3, which is referred to the zeros, minus theta 4, minus theta 5, referred to the poles, and then theta 6 referred to the zeros, equal to 2k plus 1 minus multiplied by 180 degrees. Okay. It's like an aeroplane lah, arrival and departure. Okay. For example, here for a unity feedback system shown here, find the angle of departure. Okay, angle of departure from the complex poles and sketch the root locus. Okay, so this is the complex conjugate poles, s square plus 2s plus 2. Can you give me the roots value? Denson Pao? Denson Pao.
Negative plus 1j.
Negative
Negative 1 plus 1j.
plus minus j1.
Yeah.
To be more specific. So we plot it here. So this is minus 3, minus 2, and then minus 1 plus j1. Okay. So that is your angle of departure. Theta 1 tu. Okay. So maknanya dia nak ended at infinity. So theta 1 is the angle of departure. So angle of departure is theta 1 equal to total angle of all zeros to the pole minus total angle of the poles to the pole plus 180 degrees. So using your theorem Pythagoras or all the formula, then you will get the value which is 108.4. Okay, it's just after 90 degrees. Sikit je. So this is the formula, which is 90 degrees. Theta 1 is unknown, minus 90 degrees, plus inverse tangent 1/1 minus inverse tangent 1/2, 180 degrees. Plotting and calibrating the root locus. So all points on the root locus satisfy the magnitude and angle properties. Itu mesti. We may want to locate points on the root locus and their gains. For example, when the root locus crosses the line representing 20% overshoot. So when given the overshoot, so automatically using a formula or graph, you will get the zeta or damping ratio. Or the symbol is zeta like this. So the gain K at any point on the root locus is given by the magnitude criteria. Please remember this formula: 1 over GSHS, open loop transfer function, GSHS, which is yang ni is the magnitude of GS and HS. Or product of finite pulse length divided by product of finite zero length. Example 8. For a unity feedback system that has the forward transfer function here, okay, sketch the root locus, find the imaginary axis crossing, find the gain K at the J omega axis crossing, find the break-in point, find the angle of departure from the complex pole, and verify it using MATLAB. Okay, so usually the plot is given. So let's draw the plot of the root locus using a MATLAB. Okay. So the G is equal to K equal to 1. So S plus 2. Okay. Divide S square, S hat 2 minus 4 multiplied by S plus 13. Okay, enter. So that is your open loop transfer functions, and then find the root locus G, and then the grid. Okay, and then we share the plot. Okay, so that is the plot. Can you see the plot?
Yes, Doc.
Yes.
Ivy, can you comment on the plot, please?
Yes, doctor.
Can you comment? A few words from you. No comment. Poster ke? Ivy,
Tak.
macam lembik je. Jason, a few sentences, please. Your comments. You want to be an engineer, ma? You must have a confidence to comment on the graphical plot. Listen.
Yes, sir. I think the point is on the right hand side.
Lagi. That's all.
That's all.
Thank you very much. Okay, listen and jot down my statement. From the root locus, comma, it is observed that the root locus have two paths due to two open loop poles. Okay, so it can be shown by the blue line and the green line. Correct or not? So that. Correct. So it also, the root locus also have a break-in point. But this is the break-in point. But so what is the value of break-in point? Kon Yawin.
Yes, doctor.
Break-in point berapa?
-7.
-7.
6.99.
Wah,
7.
mana kamu tahu Macam mana dia tahu Oh, dekat nose lah. Patut. Okay, -7 And what is the cross sections of the root locus towards the imaginary axis? Leong? Leong tak datang? Tak datang. Liana? Liana Camelia? Leong tak datang. Liana Camelia tak datang? Tak datang. Mahmud? Mahmud? Syekh? Tak datang. Mahmud absent. Firdaus? Muhammad Firdaus? SEL? Muhammad Firdaus?
Yes, doctor. I'm here.
What is the value of the intersection? Root locus and imaginary axis?
Kena gerakkan dia punya tu cursor.
Speaking please, we have Arab brothers.
We have to move the cursor to exactly at the imaginary axis point.
Okay, so I copy in the WhatsApp and then so we come back to the questions. Sorry, the slides. Okay, can you see the slide, guys?
Yes.
So the solution is here. This is the plot. So you can see that it starts from the poles. Okay, the locus start from the poles, and then here is the BIP break-in point. Okay, so ended at -2, and the other one is ended at infinity. Okay, so here the open loop zeros -2, open loop poles is given here -2 plus -J3. So we already have this value tadi berapa? What is the value just now? J. Adam apa tadi? Adam ke? Adam, berapa value tadi?
4.56.
Huh?
4.56.
Okay. So using the Ruth-Weiss criteria, we find the closed loop transfer functions here. Okay, so we want to validate this value 4.56 using a Ruth-Weiss criteria. So we insert inside the value there. Okay, 1, k minus 40, 2k plus 13. And then we get row of 0. The other case, row of 0 for k is equal to 4. Okay, so you will use k equal to 4. Insert inside the equations. Polynomial s squared 2k plus 13. Okay, where do you get it? We get it from here. Okay, s squared. Okay, and then you insert this value as 4 because 4 is the critical gain. Okay, gain criticals. Then you find the roots of this s squared plus 21. So the value is 4.58. Okay, 4.58. So you, in the computer 4.56, more or less the same. Okay, boleh diterima. Okay, can be accepted. And then how to, from observations, break-in point is -7. Just now, our colleague said it's -7. So how are we going to validate it? So we just took the open loop transfer functions. Okay, s plus 2 over s squared minus 4s plus 13 equal to 0. Okay, and then differentiate. Okay, use the concept d per ds, u divided by v. This is u divided by v, v du, u dv over v squared. Okay, and then simplify. So this one multiplied by 0, you get 0. Then you have these quadratic equations. Okay, so s squared plus 4s minus 21. So using your calculator or using a MATLAB, you can get the value. So now you have two value, -7 and -3. Okay. PV. PV tak ada. Tak ada. Nurul Atika.
Yes, Doctor.
Which value that you preferred as the break-in point?
-7.
Why?
Because it meet and break
Left
at that
half plane.
point.
Oh, panjangnya. You do the left half plane. Panjang lah jawapan lo. Simple-simple lah. Pening pula orang nak hadam kan. 97 is here. When you find the roots, you get -7 and 3. So from the plotting given, -7 is over here and 3 is over here. So impossible lah 3 kan. So -7 is the answer. And for the gain at -7, okay. So you have to calculate the length of length 1, length 2, and length 3. Okay. So how do I get length 1? L1. Omar Amgat. Omar? Datang. Patrick?
Yeah, Doctor.
How do you get L1?
L1.
No.
L1?
L1 is L
P square?
3 square plus 9 square.
9 square. This one is 2. 2 plus 7, 9 square.
Oh.
Same lah. L2 also same. So the value is 9.48. Okay. And then L2 direct from here. This is 2 minus 2. So it's -7. So the length is 5. Okay. So K is equal to 18. Patrick, correct? Patrico?
Correct.
Sepak. Betul tak? Sepak.
Betul.
K equal to 18. Right. And then lastly is the angle of departure. Okay. Okay, because we have complex conjugate poles. Okay, so first we draw vectors point to close to epsilon to the complex, and then at this point kita gunakan angle criteria, okay, which is inverse tangent 3/4 minus 90 minus theta. This one is the theta departure equal to 180 degrees. Then we will get the values which is minus 233.1. And finally, this is the plot. Okay, usually this plot is given in the test and exam, so you don't have to worry. The important thing is you must know what is this point, what is this point, how many root locus paths, how many complex conjugate poles, what is the gain value over here, what is the gain value over here. Okay, that's why you have to know that. Okay, so don't worry about the plot, right? Okay, and this one is the details. All right, so we have a rest for 10 minutes. Okay, can we have a rest 10 minutes, guys? Boleh rehat sekejap?
Boleh.
Boleh. Okay, guys, we continue the second part of the lecture today by referring to the slide number 72. Can you hear me?
Yes.
Right. So example 9, page 72. So for a unity feedback system that has the forward transfer function, which is here, the open loop transfer functions, sketch the root locus and then verify it using the MATLAB. And then find the key so that the system operates on the damping ratio 0.5 and compare the value obtained using your MATLAB, right? So we draw first lah. We draw first the root locus. So G is equal to 1 S multiplied by S plus 1 multiplied by S plus 4. Okay. Close bracket. Okay, that is your open loop transfer functions, and then R locus G. Okay, go there, and then grid. Okay, so that you can have a grid over there. So share the values, the figures. Okay, can you see the plot, guys? Can you see the plot?
Yes.
So as usual, we focus on the important part here, okay, by positive magnifying glass. Okay, so it become bigger, and then reset again. So what information that we want to find here is first, if the question asks you to give a few comments on the plot, just say that the root locus have 3 paths, okay, which is the shown here, the yellow one, the green one, and the red one. Why 3 root locus paths? Due to the 3 open loop poles, which is S equal to 0, -1, and -4. That is number 1 comment. Number 2 comment is the breakaway point occurred here. Okay, breakaway point, because breakaway point occurred between 2 open loop poles, which is here. Okay, so what is the point there? Simi Chin? Simi.
Hi, Doctor.
Hi. You see me today, so see me change what is the value of the break-in point?
Need to
There,
negative
in your laptop,
0.464.
minus 0.464, jot down. Okay, jot down the value and then Yip Wen Jin.
Yes, Doctor.
This class ramai budak perempuan Chinese ramai sangat. Okay, what is the intersection between root locus and imaginary axis?
Nah, haven't reached.
Haven't reached Huh?
Yeah, need to be a bit, right?
Lagi.
Yeah. 2.07.
Kan tak boleh
One more.
dampingnya negatif lagi tu.
Few more.
Dia mesti
Yeah. Two.
okay.
Two I.
Yeah.
Yeah.
Satisfied So the value of the point
2J.
J2 mah.
J2.
J2 gain dia 20.1 kan. Jot down. Jot down, nanti kita nak validate dengan calculation. C micin break in point minus 0.464 and the gain is 0.879. Baby sudah nangis mah. Dengar tak baby nangis? Okay. I share the plot. Dapat? So here you are required to find the intersection between the damping ratio zeta 0.5 and the root locus. Okay. So as we know that cos theta equal to zeta, so theta is equal to inverse cos 0.5, which is 60 degree. So you have to use this tool. What is the name of this tool? Yuki Wong?
Pass.
Huh?
Pass.
Pas?
Compass.
Kompas. Oh, kompas. You pakai kompas. Zulhelmi, what do you call this ruler?
Apa tu yang separuh pembaris tu? Lupa. Bukan.
Protector.
Protector.
Protector. So for the protector here, you put this red circle at the origin. Okay. And then 60 degrees is something like that. Okay. Theta. Right. So this is the point of concern, the intersection between zeta 0.5 and the root locus. So it happened at minus 0.396 plus j 0.689. Okay. Point 2. How do I get this point? How do I get this point? Okay. First, if you have this type of question, this figure, you print out using your printer. Okay. Please print out using your printer and then take this ruler, put on the origin, and then you draw the straight line for 0.5 at 60 degrees. And then you attach this figure inside your answer script. Okay. Do you understand? Do you understand? You Rajan? You Rajan tak datang. Alimin, do you understand?
Yes, doctor.
Safwana? Safwana?
Yes, Doctor.
Orang nak tanya sikit, how you draw zeta line using MATLAB? Mana? Safwana? How you draw?
Tahu, Doktor.
Nak lukis kat sini ni supaya komputer keluarkan benda tu dekat MATLAB ni. Tak tahu.
Tak tahu.
Tak tahu. Tak apalah. Tak tahu. Buat macam ni. Sambung tadi kan. Tadi tu tadi you buat ni kan. S, lepas tu G kan. Lepas tu R, locus G kan. Lepas tu you tambah Z sama dengan 0.5. S grid. Z kosong. Theta pula. Kosong.
Cannot see, doctor.
Wait. Wait. Okay. Okay. S sama dengan TF tadi tu kan. TF bracket S. Then G tu you key in lah. Dia punya open loop tu. Kan? You key in the open loop. And then R locus G. Then Z equal to 0.5. The damping ratio. Then S grid Z0. Let us type on the okay. Tadi dah type ni, so tambahlah Z, just add. Z equal to 0.5. Okay. S grid Z, 0. Okay. Enter. And then goes to the plotting tadi. Sapwana, can you see the line there?
Yes, but not clear.
Not clear. How to make it clear? Anybody knows? Yeah, garisan ini. Okay, so this is the point that our concern is 0.5. I share the concept. 4.99, 0.499, subsoil 0.5. Okay, so the pulse is minus 0.4 plus J 0.69, which is more or less same like what we find in the slide in 73. Okay. Still, okay, edit, copy figure. Okay, in your WhatsApp plot. Anybody knows how to enhance the zeta line? Anybody knows? Nanti assignment dipandai lah buat. Anybody knows? Semua tak tahu mah. Okay, maybe you have an idea or shy to give an idea. All right. So that is the point using MATLAB. Okay. So we continue. Okay, so this is the point. Okay, so I enhance already using paint. So I get the value there. Okay, and the gain is 2.66. Okay, how do I get 2.66? Sharif.
Yes, doctor.
How do I get gain 2.66 by calculation?
I'm not sure, doctor. Oh, okay.
L1, L2, L3. So K is equal to L1, L2, L3 mah. Okay. So you kira sendiri mah L1, L2, L3. Boleh? Okay.
Alright, doctor.
Yes. Ada kat sini ya. Tak baca lah. Tidur Tidur tu.
I'm writing the coding to enhance the line just now.
Oh, okay. You share with me lah. You share with me lah.
Okay.
Okay. Bagus budak ni. Bagus. Okay, so this is the method how to calculate gain at this point. Okay, so I hope everybody's alert about it. And then this is the results, okay, the intersection point. Okay, damping 0.5. Example number 10. Sketch the root locus for the system and find the following. So you now have a open conjugate conjugate zeros, open loop conjugate zeros here. Right? Open loop conjugate zeros. Okay, and then open loop poles -2 and -4. Again, zeta 0.45. Find the range K for stability, compare result with FUA'AD. So now we plot, because in question, plot is given. Okay. So just type G because we declare the S already. G is equal to Aina Wahida.
Yes, Doctor.
Codingnya
S
K
power
equal
of
to 1, K equal to 1, okay.
S power of 2
S hat tu lah,
minus 4 multiply S
okay,
plus 20
it's 20. Then divide
over S plus 2 multiply S plus 4.
Right, S plus 4. Okay. Betul?
Betul.
Macam salah. Bracket dulu kan? I think it's bracket first. Better bracket. Kan? Oh, dah. Betul.
Ya, betul.
Supaya dia kira yang tu, otherwise dia akan kira 20 over. Yang depan tu dia tak kira. Right, okay. And then sambung.
R locus G.
R locus G. Okay, then sambung.
And then grid.
No need grid because zeta ni kita nak buat zeta.
Z equal to 0.45.
5. Okay.
And then S grid Z.
S grid Z kosong. Kosong tu origin lah. Zeta tu is the value of the damping ratio.
Okay.
So for those yang maybe don't understand why 0 over there, 0 is due to origin because the line start from the origin straightforward up at 0.45 damping ratio. So kenapa tak nampak? Because I don't share. So I have to share here. Can you see the plot? Can you see the plot, guys? Guys, can you see the plot?
Yes, Doctor.
Okay. Ni Azim.
Yes, Doctor.
Ni Muhammad Azim.
Right.
Ya, saya.
Boleh tak demo give a few sentence on this plot?
There are two paths for root locus.
Okay, why?
There are two open loops.
You do two
poles.
open loop poles, -2 and -4. Okay, number
Yeah.
1. Number 2.
The breakaway point is
Breakaway.
at
Okay, breakaway. So saya scan ya. Breakaway dia. Okay, what is the value of the breakaway?
negative 2.88.
Negative 2.88. Okay. Number 2. Number 3.
Tak ingat dah. I don't remember.
Closing ni?
Oh yeah, the crossing at imaginary axis is at 3.9 J.
Then the intersection. 0.4.
The intersection. -1.5.
So in case you are not really good handling a mouse, you have to do some stretching. Okay. Stretching, tahu stretching. Huh? Macam Chris Leong. Boleh tak? Okay, can Okay, edit as usual, share with others. Okay. Right, so come back to the slide. I hope everybody understand. Okay. So this is the plot just now. Okay. Just a point of concern adalah damping. Tengok damping. Okay. So this part usually damping is equal to 1. Okay. And this part usually damping equal to 0. Okay. So this part yang blue line, blue shaded line. Okay. Damping is 0, zeta equal to 1. Maknanya stable region. Stable region. So usually the system will operate at the stable region. Okay, so giving damping ratio 0.45, cos theta equal to zeta, inverse cos 0.45, 63.26, which is located here. Okay, Safona, betul
Betul.
Then draw a straight line from the origin here and cut the root locus. Okay, intersection dia adalah yang ni. Okay, maybe the answer is different. Okay, Atika answer different, Noraina different, Safona different, but not much. Okay, as long as in this region. But if your answer is minus 15.3 plus J 30.3, of course this answer is wrong because it's too far. Okay. So calculate the gain of K at this intersection point. Okay. So L1, L2, L3, and L4. Okay. So I hope you know how to calculate. Just add here. If you have printer, you print. Okay. Then the gain is 0.417. Natra Hasan. The WhatsApp figure that I post just now, what is the value of K at this point? Natra?
Yeah.
Berapa nilai K dia dekat point tu? Lambat ni. Wah, 0.415 kan?
0.415.
0.415. Kau tidur ke?
Pening sikit sebab saya ingat.
Macam tidur je. Lambat jawab. 0.415. Ni 417. Lebih kurang je. Lebih kurang je. Okay. So it's okay. Then the intersection point here, kita by observation tadi kita dapat berapa Natra? The point over here, J berapa?
3.9.
3.9 from the WhatsApp.
Oh yeah.
Okay, gain dia berapa?
1.51.
1
51.
zeta dia?
Minus 0.0022.
0 mah.
0.
So precise. Budaknya terperinci Sinatra ni. Okay, right. So open loop transfer function. This is open loop is given. So in the test and exam, you have to find the closed loop. Okay. Find the closed loop. Then find the characteristic equations here. Okay. 1 plus k s square 6 minus 4k s plus 8 plus 20k. Okay. And then put inside the root width. Okay. Put inside the root width, this one. Okay. 1 plus k, 6 minus 4k, 8 plus 20k, and 0. Okay, then continue. Okay, then continue. So I hope you understand and know how to find this. Okay. Jangan tak tahu tanya kawan yang tahu. Tadi dah tunjuk. So stability, stability is as the theory just now. First column, mass greater than 0. Okay. So this is the first column. Okay. So 1 plus k greater than 0, k greater than minus 1, question 1. Then 6 minus 4k greater than 0, minus 4k greater than minus 6. So k less than 6 divided by 4. Berapa? 6 divided by 4? 1.5 kan? And then 8 plus 20k greater than 0. 20k greater than minus 8. Minus 8 divided by 20. So basically the range is from 0 to k to minus 1.5. Negative gain is not included. Okay, usually gain in positive value. Okay. So we understand that when the locus cross here, okay, the gain is critical. Okay, critical. Damping 0, but the gain value is critical. So you must understand between the gain k versus zeta is two different things. Okay, so at this point, the gain is critical. The zeta is 0. Okay. So in order to make the system critical, k is equal to 1.5. If 1.4 stable, 1.49 stable, 1.5 critical, 1.55 unstable. Okay, so inside the value k here, then you have these quadratic equations factorized. So is plus minus j 3.9 macam si Natra cakap tadi. Okay. Boleh Natra, boleh faham? Okay, so this is overall. Okay, overall values. You can see that here dampingnya is zeta is equal to 1. Sini zeta-nya equal to 0. This region zeta is between 0 and 1. Okay, so zeta equal to 1 ni kita panggil dia sebagai critical damp. Sini zeta 0, kita panggil dia undamp. But sini juga kita panggil dia sebagai K critical ataupun critical gain. Tak sama. Critical gain and critical damp is two different things. The problem with the previous student, they assume zeta critical damping and critical gain is the same. So that's the problem. Always like that. So make sure this section 5 and 6 can differentiate between critical gain and critical damp. And finally, the breakaway point is over here. Okay, so just find the open loop transfer function which is given and then differentiate. Okay, differentiate using the u over v concept, which is v du, u dv, and over v squared. And then you get this quadratic equations, and then you have two points. Okay, so as usual, 2 points. How are you going to choose? Nur Hazika? Nur Hazika Shazwina, where are you?
Ni doktor.
Kamu sabar ba? Sabar ba? Hazika? Jauh sangat lah. Ashraf? Ashraf Ruslan?
Yeah, doctor.
Which one you want to choose? Minus 2.85 or positive 5.25?
Minus 2.85.
Minus? Why?
2.85. Because it located at left hand plane.
Bukan left hand plane, left half plane. Left hand ni tangan kiri. Left half plane. Cuba sebut.
Left half plane.
Bukan left hand. Tak boleh. Maafkan. No problem. I'm okay. So question 11, example 11, the last one. Okay, so the last one as usual, we have what do you call this? Complex conjugate pools. Okay. So open loop zeros minus 2 minus 4. Can you find the roots for this? Zarif, can you find the roots? S squared plus 6s plus 25. Zarif tak datang? Asnawi?
Ya, doktor.
Roots dia berapa?
Dia
1, 6, 25. Kalau pakai calculator, saya pakai MATLAB. Apa? Tak ada calculator
cari.
Ha?
Boleh cari.
Cari, astagfirullah. Muhammad Daniel. Muhammad Daniel.
Negative 3 plus minus 4J.
Negative 3 plus minus J4. So kalau pakai MATLAB macam mana? Tu pakai calculator, pakai MATLAB. Just type the vector for the quadratic equation. Okay, katalah P 1, 6, 25, then roots P. Okay, so you give you the answer as shown in the MATLAB here. Okay, so kita draw lah. So macam mana nak draw? Faris, Haikal.
Yes, doktor.
Nak draw. A1, so S minus 2 multiplied S minus 4. Nah, sebenarnya S
plus 2
square plus 6 multiplied by S
plus 25.
Plus 25. Then R locus G. Kan? R locus G. Okay, dah dapat drawing. And then damping ratio 0.5 macam mana?
Z equals to 0.5.
0.5. Burung kat rumah kau.
R.
As grid Z origin. Kan? Okay, so we see the plot. Okay, you see the plot. Okay. Irfan. From Irfan.
Yeah, Doctor.
A few sentences from you, comment on the plot. Number 1. Ni, apa nak komen? 2, root locus path, correct?
Yeah,
Due to two open loop poles. Two open loop poles, ya kan? Nombor 2, ni apa ni? Break in ke, breakaway ke, break up point ke apa ni?
Breakaway.
Kenapa breakaway? Because breakaway ke break in?
Breakaway.
Hah?
Breakaway.
Salah. Bukan breakaway, break in tu. Break in, dia berlaku, it happens between two zeros. Okay. Ini dia. Apa value dia? Positive 2.9. Correct?
Yeah.
Gain dia berapa? Catat. 51.3.
Oh.
Okay. Slow sikit budak ni. Asif. Asif.
Ya, Doktor.
Next, number 3. Intersection with imaginary axis.
The
Banyak apa ni? Apa tu?
the imaginary axis 4.05.
J 4.05.
J 4.05.
And number 4, the intersection with 0.5.
J 4.19.
0.45 ke 0.5? 0.5.
0.45.
Tu dia. Tu dia. Okay.
J 4.18.
Okay. Copy figure. Share. Sampai? Sampai tak? Sampai tak? Okay. Then this is the drawing. Okay. So ni bukan breakaway point is a break in because the locus enter the point and then ended at zeros. Jangan tak tahu beza BIP dengan BAP. Then the characteristic equations from the closed loop is here, equal to 0. Then masuk dalam row twist. Then continue the fill up, you get 25 plus SK. So dia berlaku dekat sini J 4.06. Okay, the cross sections between root locus and imaginary, and the K critical tadi berapa? K critical tadi 1.01. Okay, 1.01 yang ini. KBIP berapa? 51.3. Dan intersection ni nanti kita tengok. Okay. Nampak? So K break in kat sini 51.3, 2.89, and then the damping ratio is -1. Why -1? Why negative damping? Because it's on the right half plane. Okay, that is non-stable region. So we have 3 region here. Yang ini is the, okay, this part is the stable. Okay, this part is the unstable. And this part is the marginal or critical gain. Sorry, critical. Okay. So at the cross-section point here is the damping ratio is 0.5. Okay. And the intersection is minus 2.2 plus G 4.18. At the operating point, overshoot 16.3. Okay. 16.3. And the undamped natural frequency 4.8. Right, Nur Atika,
Yes, sir.
dah habis. Slide number chapter 1 dah habis. So tutorial, you just read by your own lah, boleh guys? Can you read by your own? Boleh,
Yes, doctor. Yes, doctor.
nanti Wednesday we go to the chapter number 2. I will share the slide later. Okay, I will share the slide later. Okay, is there any question you want to ask? Satisfied with the delivery? Si Michin, are you satisfied with the delivery?
Yes, very satisfied.
You tak pening ke? I switch from iMac to iPad and then iPad to MATLAB, Zoom and so on.
Tak, very clear.
Very clear, HD My YouTube belum is HD version. Very clear. That is for your revision lah after the class. Maybe in the class you don't understand or a little bit slow due to puasa. Si Michin, you puasa tak?
Tak.
Puasa malam Malam ni puasa lah, malam ni tak makan. So hari Rabu kita jumpa next Wednesday. Alright brothers, are you there? You share? Akhi? Alright brothers, Ismail?
Yes, doctor.
Ada Mawjud Muhammad bin Said Taure? Are you there? Muhammad bin Said Taure? Absent. Sami Imad Lababidi? Sami Imad Lababidi? Tak datang. Syomik? Ismail, what time over there?
Sorry, doctor.
What time over there? Sign.
Sorry.
Time.
Now 12:42.
Oh, you in Malaysia?
Yes, I'm in Malaysia.
Oh, I thought you in Syria. You're from Egypt?
No, from Syria.
Oh, from Syria. Felix Erickson, are you there? Felix Erickson? Absent. Amjad Tariq, are you there? Amjad Tariq. MashaAllah, everybody is sleeping. Okay, never mind, it's okay. So any question you want to ask? Wan Muhammad Alimin, ada apa nak tanya?
Tak ada apa.
Bagi ni lah.
Question, Doctor.
Alimin, apa ni? Okay, so if no class, I see you on Wednesday. Okay. So Atika, no titik wakaf because we're going for chapter 2. Thank you very much. Bye, guys.
Thank you, Doctor.
Bye.
Thank you.
Thank you, Doctor.
Thank
you, Doctor.
Jazilan.
Thank you, doctor. Terima kasih, doctor.
Sesi ni